A couple of weeks ago, I did a video making the ultimate Bluetooth speaker. And a lot of people enjoyed that video, but the most common request was, can I do a version where I make it cheaper? And the answer is absolutely yes, and that's what we're doing today. The first thing we need is a battery, and for that I'm going to be using some 18650s in a pre-built 3S battery. That being said, we do still need to add a BMS and a charger. So let's do that. I do this every video, so I'm not going to walk you through the process of how to do it again. If you don't know, just check out one of my other videos. Now that we have a battery, it's time to move on to the charger. And for that, I'm going to be using this charging boost board from AliExpress. It takes a USB-C input and outputs a charging signal for a 3S battery. Unfortunately, in an audio sense, the poor noise control on the output will introduce a lot of noise into our audio signal. In order to mitigate this, I'm going to be adding two 470 microfarad capacitors to the output to smooth it a bit. Now that we have battery and charging sorted, it's probably a good time to start working on the speaker components. And the first one I'm going to do is the amplifier. The amplifier board I'm using is the TPA 3110XH-A232. Which is a Class D amplifier supporting up to 30 watts per channel. Connecting it up is pretty simple. We take the positive from our battery and connect that to the VCC on the amplifier board. We then take the negative from the BMS and connect that through a switch to the ground on our board. An amplifier is not much good without speakers, but connecting up the speakers isn't as simple as just wiring them in. For these particular speakers, I'm going to be using something called an RC low-pass filter to slightly alter the frequency response. The RC filter I'm using for this project uses a 6 ohm resistor and a 1 microfarad capacitor. This does increase our impedance, so to pair with this, I'm going to be using 4 ohm speakers. It seems like we're pretty close to being done, and we are. But it's not a Bluetooth speaker without Bluetooth. So let's add some Bluetooth. Although my amplifier can handle a huge range of voltages, between 8 and about 40 volts, that's not the case for the Bluetooth receiver chip. That requires a steady 5 volt output. So how do we achieve that? Well, in order to do that, we're going to be using something called a voltage regulator. So how do they work? On the board here, I have one of the simplest forms of voltage regulator, a Zener diode voltage regulator. And this is how they're typically set out. But I don't like that as an explanation, so I'm going to quickly readjust this and change it so you might be able to understand it a little bit better. I've rearranged this circuit diagram now, and it looks a lot like another type of circuit. If I were to replace this Zener diode with a resistor, what we would have here is a potential divider, with R1 here and R2 there. And as we know, by varying the resistance of R2, we can change the output voltage at the middle here. So the question is, how does this regulate voltage? Well, a Zener diode has something called its Zener voltage, which is a constant voltage drop across it, regardless of current, as long as you're within range. So basically what that means is this will act as a variable resistor to maintain a fixed voltage at this output. Zener diodes aren't perfect and have a huge variation in voltage. Actually, I've got this in a book somewhere. Hold on. Here we go. This book is ridiculously heavy, but you can see here, a Zener diode has quite a poor voltage curve, which means that depending on the amount of current coming out, this voltage might be nowhere near where we want it. So instead of a Zener diode, we use a 2-terminal reference voltage IC, which is basically an integrated circuit to act as a much more ideal Zener diode.
But these circuits have a problem. They can only supply a very small amount of power. So what they need is some kind of power amplifier. And that's a little bit complex for this video. So we're just going to buy an off-the-shelf voltage regulator.
Connecting this up is not that difficult. We connect the positive for our Bluetooth board to the positive from our voltage regulator. We then connect the negative from our Bluetooth board to the center pin of our voltage regulator. We then connect this center pin to the ground wire after the switch. Finally, we connect the left pin to the positive of the battery. In order to connect the Bluetooth board to the amplifier's input, we simply wire the ground to ground, the left to left, and the right to right. Now that we have a fully functional speaker, it's time to build the enclosure. And this is not as simple as just putting things in a box. The design of the speaker enclosure is incredibly important because speakers vibrate back and forth to generate sound. And a lot of people think that this vibration causes sound to come out of only the front of the speaker. But that's not the case. As speakers vibrate, the backside of the speaker also generates a sound wave. Now, a way a lot of people get around this is by creating a thick wooden box and then filling that with some kind of sound deadening material to effectively cancel out the wave generated by the back of the speaker. I did this in my last video. But this time I want to utilize that. And in order to utilize it, what I'm going to do is design a complex duct system to spit that sound out the front of the speaker, hopefully at the right time so it's in phase with the sound coming out of the front of the speaker. Alright, this is all loaded up. It should all work now. Obviously, I haven't 3D printed the outer case, but before I do that, I want to test that it works. So let's turn it on.
The Bluetooth device is ready to pair.
I'm not sure if that came across on microphone, but it just, I would imagine not. Actually, I have a ultra loud noise cut out, but it just said Bluetooth enabling or something like that, and then screamed that. Let's try and pair it with my phone. Now for the sound test. The song everyone always uses in their cars is a song called 16 Tons by Tom Morello. Let's have a listen to that through here.
Some people say a man is made out of mud. Poor man's made out of muscle and blood. Muscle and blood and skin and bone. A mind that's weak and a back that's strong. You load 16 tons, what do you get? Another day older, deeper in debt. St. Peter, don't you call me, 'cause I can't go. I owe my soul to the company store.
It sounds a little bit tinny, so in order to fix that, I'm just going to add some sound deadening material into the edges of the speaker and hopefully deaden it a little bit. Now we need to slide this internal thing into the outer speaker shell. Unfortunately, I did make a little boo-boo when assembling it. Shoot, what did I just do? Basically, I accidentally short-circuited the voltage regulator. But I thought this was a fantastic time to swap it out. And what I'm going to do this time is add an isolated power supply, so I can hopefully get rid of the buzzing noise. It didn't really come across on the video, but when the speaker was on, there was a little bit of noise. And that wasn't ideal. And this way I can cut that out entirely. Dude, this is actually so loud when it goes off. I don't know if it comes across on camera. But this is a solid speaker. I've 3D printed the outside out of solid plastic, so it's robust, it's strong. Right, this could actually be a Bluetooth speaker. So yeah, Hope this tutorial helped you, and I guess we'll... Well, and now we have a pretty nice speaker. I would show you close-ups of it, except I forgot to do that. And now I'm in the United States on the other side of the world and don't have the speaker. Of course, all the design files will be on my website, probably next week because it takes me a bit of time to get round to it. Hope you guys enjoyed the video. Please consider subscribing and I will see you soon.